Protection of Information Assets, Part 5. Well, if this were a golf tournament, we would be on about the 16th hole, rounding out the back nine. Or it'd be the final stretch of the Preakness. Or if you prefer, we're finishing up the 7th inning stretch at a baseball game. And you've just finished singing Take Me Out to the Ballpark. Well, pretty soon, you'll be singing Take Me Out to the Test Site to sit for your CISA exam. But we've still got to use a NASCAR reference, close out the final laps towards that checkered flag. In Protection of Information Assets Part 5, we're going to cover 4 key topics. First of all, we'll look at auditing the Information Systems Management Framework, auditing network infrastructure security, physical access controls, and then finally, environmental access controls, which will lead us into our final 2 nugget movies. The framework for auditing IS management really involves several key tasks, and none of these should be too much of a surprise to you. It's almost kind of a review of information we've covered so far in this CISA series. As an auditor, you want to review the written policies. There must be written policies in place. You want to review those and review the standards and processes. Make sure that you have processes in place for securing physical and logical assets. Once you have written policies in place and you've reviewed those and made sure they're up to standards, you want to make sure you have proper training and awareness, especially of new users. By training new users in information security information systems from the outset, it's going to prevent having to deal with other problems later on. Next, you want to go through and classify all of your data and all of your assets. Also assign ownership of that data and those assets. Those will be all part of your baseline security configuration. Then you'll identify who the security administrators are, who are the security practitioners, all the way up to the CIO or the Chief Security Officer, and you want to know the chain of command all the way down to the owners of all of the logical and physical resources. You'll of course want to document all of the authorizations for group membership. For example, most enterprise organizations base their security upon security groups who have access to resources and rights to resources, and they place membership into that group. You want to analyze and document all of the group authorization. Again, the goal here is to make sure that users only have as much access and authorization as they need. No more, no less. As a matter of fact, you'd be better off having less authorization to activities and then granularly add access than to give group membership more access than they need. And then again, by training new users, hopefully you won't have to terminate users based on security breaches. If that happens, then you want to make sure you have a process in place to make sure that you handle voluntary resignation, firing, scheduling, all these different things. And again, we want to make sure that our new IT users are trained properly, okay? Make sure that they read and agree to follow security policies. Make sure they understand to keep their logon IDs and their passwords secret. They should lock their terminal screens when they're not using them. They should report suspected violations of security. They need to maintain good physical security and conform to applicable laws and regulations. And hopefully, you won't have to terminate an employee based on a security policy breach. Again, from a practical standpoint, the first step in information technology security is creating a security baseline based on the existing infrastructure. So here's a laundry list of things that you should create in that baseline report. First of all, an inventory. An inventory of the computers that are going to be managed, the inventory of all the network-aware systems, operating systems, ownership, data ownership, software applications. So you want to establish and maintain an inventory. Then patching. Make sure that your applications and network operating systems are patched for security breaches. They have updates, and this should be an automatic process, especially workstations. Then make sure you have a password policy. Understand the importance of strong passwords, as we've alluded to earlier, that you have this in your security policy, and do regular audit checks to make sure that the password policy is in place and being adhered to. Antivirus solutions, anti-malware, host-based intrusion prevention systems. This should be a security suite installed at least on each workstation with automatic virus signature updates. at least on a weekly basis. Then, are you hardening your systems? In other words, on your servers and workstations, are you only running the necessary services that you need? If you don't need a service, then disable it. For instance, I'll go to the Start menu and go up here to Control Panel, and then on my XP machine in Control Panel, I'll see an Administrative Tools applet where I'll find the Services area. In the Services area, I can go down and look at all the different services that are running. You can see the description and the status. Is it started? Is it startup type manual, automatic? I can scroll down and go through here, and this can be done also through a policy, a configuration management policy, let's say through Windows Active Directory, which wouldn't be a bad idea. But on a case-by-case basis, I might say, you know what, I don't need this telephony service. It starts automatically. I could double-click on it, and I could say, you know what, this may be creating a security vulnerability for me, so I'll have the startup type. Instead of choosing automatic or manual, I'll just choose disabled. I can also stop the service right now. Stop it and disable it. So I might want to find services in here that are running that may be creating vulnerabilities for my end users and go ahead and have these disabled or at least starting manually and not automatically on the system. This is part of system hardening. Also, if we go back into our control panel, we would want to go to Add Remove Programs. We want to remove any programs on our system that are unnecessary or that use ports for remote access or port 80 for HTTP. If you're not using it, if you don't need it, if it violates your security policy, go ahead and remove the program. If your end users are using peer-to-peer file sharing programs, for example, you want to make sure those are removed from your system. So this is basic system hardening. Environmental issues. We're going to talk more about the environmental issues here in just a moment, but this is also part of the baseline. Making sure that you have the right type of environmental and physical network ecosystem in place. Physical access through doors, physical security, closed circuit television, armed guards, sign-in sheets, electronic locks, those issues. We're going to focus on these here as well. Do you have regular assessment, risk assessment, looking at the known threats and vulnerabilities of your organization? Have you looked at weak spots? Okay, this will mean doing some penetration testing and finding those weaknesses and assessing the organization's acceptable risk. Do you have a backup and recovery strategy, backup of applications, backup of data, and a recovery process? Business continuity, and we're going to spend quite a bit of time in this, especially in the last two nuggets, actually, looking at business continuity, business impact awareness. Who is your IT staff? We alluded to this earlier. Who are your administrators? Who are your security practitioners? And again, of course, always very important, training and awareness. This is all part of your security baseline and analyzing the posture, the security posture of your organization. How do we as auditors identify risks to information, to data in transit and data in storage, the logical access? Well, we do it using documentation, existing documentation from the professionals who went before us, documentation and reports that are generated from the security baseline that we just talked about, doing inquiry of security practitioners, administrators, and data owners, conducting interviews, general observation on a weekly basis. Again, this is all part of that baseline process. What are the results of that interview and observation process? Evaluation and overall risk assessment. This is going to allow us to find out what all the risks are, the present risks, the clear and present danger to our information and data processing systems. You want to evaluate the controls that we have over the access paths. What are the access paths to data? And this again, of course, the input and output path through a workstation or a terminal or a laptop or a Wi-Fi device, egress and ingress points into servers, network-enabled appliances, into and out of our organization, our intranet, our extranet, our remote access, our site-to-site wide area network connections. Again, document all this information. This really goes back to just mapping out and documenting the network infrastructure. You want to observe the inadequacies in hardware and software security features. Use the World Wide Web for this. Go up and do searches on the different hardware platforms you're using, different hardware, software products. Go into the bulletin boards. See what the users are saying. Look at consumer reports. Look at some of the security alert websites like sans.org, for example, for vulnerabilities in operating systems and web-enabled applications. Test your access controls. Test, and test again. As an auditor, testing the access controls means actually going into the organization and using the mechanisms, using the smart cards, using the keys, the USB keys to get access, create audit accounts, and get access with these accounts and test these against the authorization and access to systems and resources and applications. You should have a list of access that's linked to the inventory of the terminals or the workstations that get access to servers and network resources. Test out logon IDs and passwords. You want to make sure that you have periodic change requirements built in. How do you disable and delete inactive logon IDs and passwords? Test for the password syntax, that strong passwords are being enforced. Test for automatic log off of unattended terminals. Test for automatic deactivation of terminals after a certain number of unsuccessful logon attempts. Test your application controls. What are your access to applications and programs? Explore the logging. Are you using syslog servers? Okay. What's being logged? You have several different levels of logging access. Are you generating too much logging information so professionals don't have time to go through and investigate the logs? What types of reporting do you have? What programs are you using to generate reports and summaries? You want to perform penetration testing, and we're going to talk more about penetration testing here in a second. Also, conduct random social engineering, which means basically calling directly into a department on a phone line, calling the receptionist. This is almost kind of like the mystery shopper, where you call in and you try to get information by using social engineering techniques against an employee. If they mess up and give out information the first time, issue them a warning. If it happens again, then terminate them. Also, test your remote access. Is your VPN working properly? Are you allowing only interesting traffic to be encrypted? Is traffic even being encrypted? Okay, you can think that the VPN connection set up properly, traffic is passing through from your remote site to your headquarters, but is it actually being encrypted and decrypted? So test those access controls thoroughly. Review the written policies, review the reports, review the manuals that come with the software and hardware. Get familiar with the IT environment, especially if you are an in-house employed auditor. Now, I've already alluded to this concept already, but I want to go into greater detail because this can be a very major aspect of a security audit, and that is a penetration test. Penetration testing is done in wired and especially in wireless networks. The goal here is to simulate the malicious user. You understand how to use the tools and the techniques that a cracker or a hacker or a malicious user is going to use to launch various types of attacks against your network. Reconnaissance attacks, access attacks, denial of service attacks, and the like. You do this to evaluate the security of your security system, computer system, or your network. So this is a process of penetration testing and assessment. Now, there's really a couple of different types of testing. We have what is called black box testing and white box testing. With a black box test, you're assuming that there's really no prior knowledge of the infrastructure that you're testing. So the testers have to first figure out the location and the extent of the system before they start doing their analysis. The other end of the spectrum is white box testing, where the testers have complete knowledge of the infrastructure being tested, and they'll use network diagrams, IP addressing information, the source code, and the like. Now, you can also have what was kind of a combination of black box and white box. This would be referred to as a gray box test. Penetration testing may also be described as what's called full disclosure, partial disclosure, or a blind test. Again, all of this based on the amount of information that the testing party has. Now, the test can range from just basically a simple scan using port scanning tools or IP address scanning tools, or maybe a wireless local area network scanning tool like AeroP, to a full-blown attack and audit. This will often be done to test firewalls and intrusion prevention systems, as well as trying to decrypt data. When you begin the testing, start with the internet-facing systems. These are your most vulnerable. Any kind of ingress and egress links to the untrusted networks. And you want to try to do this if you can before you actually deploy the system. Now there's several different methodologies for doing penetration testing. And there's really three key techniques. Let's take a look at these real quick. This first is the OSSTMM, the Open Source Security Testing Methodology Manual, and this is basically a peer-reviewed method for performing security tests, penetration testing, and metrics. The OSSTMM tests information and data controls, personnel security awareness levels, fraud and social engineering control levels, computer and telecommunications networks, wireless devices, mobile devices, physical security access controls, security processes, and physical locations like buildings, perimeters, and military bases. The OSSTMM is also known for its rules of engagement, which kind of lay out how the test is done. You definitely want to add this to your knowledge base. You can also download the manual from isccom.org. Another option is the National Institute of Standards and Technology, or NIST. They have several special publications. 800-42 is their guideline on network security testing. Let me go down here to it. -42, here it is. And you can download this in a zipped format or an Adobe format. This is not as comprehensive as the OSSTMM, but it's also very likely to be accepted by regulatory agencies. As a matter of fact, NIST refers to the OSSTMM in this document. Finally, we have the OISSG, the Open Information Systems Security Group, and they actually have the Information Systems Security Assessment Framework, the ISSAF, which is also a peer-reviewed structured framework that categorizes information system security assessment into several domains. It also gives specific evaluation and testing criteria for each one of these domains. The ISSAF is not as mature as a solution as the ones that have been previously mentioned, but you would want to go ahead and make this one of your favorites. You want to add these three sites to your knowledge base and spend some extra time exploring more about penetration testing as defined by these three documents. Another vital area that the auditor may be involved with, and this is something that happens kind of after the fact, proactively, once there's a security breach or an incident, and that is computer forensics. Computer forensics is a technological, systematic approach to inspecting a computer system and the contents of that system for any evidence or supporting data of a crime or misuse of the computer. Computer forensics is also known as electronic evidentiary recovery, with the goal of answering questions about the state of digital information and events on that digital information. Computer forensics is typically applied to data storage devices, or basically any form of technology that can be used to store or transmit data. When collecting evidence of an offender's network, typically you'll look at the workstation of the offender, a server or servers accessed by the offender, and the network that connects those two endpoints. When using forensics, you have to follow standards of evidence so that the information is going to be admissible in a court of law. You don't want it thrown out in a technicality or make yourself susceptible to some kind of civil lawsuit. So as an auditor, if you're doing computer forensics, you want to handle the original evidence as little as possible. You don't want to change the data. You want to establish and maintain a chain of custody of the hard drive, for example, never having a gap in the custody of that object. Document everything completely and never exceed your own personal knowledge. Don't hesitate to bring in experts if necessary. The computer forensics process, if you look here at the bottom of the screen, typically involves examining, powering down the device, looking for traps or booby traps placed by the offender, document the process fully, duplicate the drive or drives, and do a review of the email system, which is optional as well. A computer forensics expert is going to go through really 4 phases of the process. First of all, identify the sources of digital evidence or documentary evidence, preserve the evidence, analyze the evidence, and then finally, present the findings to the interested parties. If you go to the U.S. Department of Justice, you can refer to the document Searching and Seizing Computers and Obtaining Electronic Evidence in Criminal Investigations. Well, we've talked a whole lot about logical access controls, access to data, network infrastructure, data in storage, data in transit. But what about physical access controls? This is also a part of the written security policy. As an auditor, you need to be aware of the physical access exposures, things like unauthorized entry to the building, the possible damage, theft, or vandalism to equipment or documentation, the ability for unauthorized users to copy or view sensitive or copyrighted information, intellectual property, preventing alteration of sensitive equipment and information, preventing the public disclosure of sensitive information or intellectual property, stopping the abuse of the data processing resources, and things, unfortunately, like blackmail and embezzlement. These are all parts of physical access exposures. Now, who are likely suspects and perpetrators for physical access? Well, disgruntled employees, contractors, temporary workers, people that are on strike, individuals who've been threatened by disciplinary action or dismissed, people who might have addictions to substance abuse or gambling, financial problems, who need quick financial solutions, people who are experiencing emotional problems, somebody who's been notified that they're going to be terminated. Former employees are also suspects, competitors, organized crime, hackers, crackers, thieves, or just somebody who's ignorant, unknowing, mischievous, and curious. Other questions to be answered are: what facilities do you have to protect on the organization and the campus? You want to start from the headquarters and move out from there. During the audit process, you're going to test all the facilities and you're going to evaluate all the physical entry paths. Keep in mind areas like where the programming is done, research and development, computer rooms, operator consoles and terminals. Where's the tape library? Where are tapes and discs and magnetic media stored? Supply rooms, off-site backup places, an input-output control room, any kind of wiring closets, telecommunications closets, power sources, disposal sites. Again, don't forget, those big dumpsters out there have a lot of information in them for dumpster divers, on-site and remote printing facilities, and of course our local area networks. Now these are all some of the big considerations. Let's look at kind of a wide variety of physical access controls to be aware of as an auditor. Now it's quite likely that this won't be your area of expertise, but as an auditor you have to rely upon the on-site facilities management and facilities personnel, as well as possible third-party contractors and consultants to help you in this area. Here's a nice list of some physical access controls, of course, going beyond just the regular key lock with bolted locks, maybe cipher locks that have combination keypads, numeric keypads, or dials to get entry. These combinations should be changed at regular intervals, especially if a key employee is transferred, fired, or possibly disgruntled. Electronic door locks come in a wide variety of different capabilities with smart cards or codes or chip-based plastic key cards or tokens that can be used. They can also be electronic readers as well. Biometric locks that use a wide variety of the biometric mechanisms that we talked about earlier in the CISA series. You also want to make sure that you've got manual and electronic logging of access in and out of all of the different areas, going beyond just sign-in sheets, making sure that you have ID badges. These ID badges may be combined with our electronic locks or with our cipher locks to gain physical access. Many times an ID badge will have a chip embedded in it that can be used for physical access as well. Are you using video cameras, closed circuit television, security guards? These are very common mechanisms in high security areas. Want to make sure that you have controlled visitor access. All visitors should be escorted by a responsible employee. And visitors include not just friends or temporary workers, but maintenance personnel, vendors, consultants, and external auditors like yourself. You might want to make sure that all service contract personnel like cleaning people and maintenance services, off-site storage services, these should be bonded to limit the financial exposure of the organization. And then things like alarm systems, controlled single entry points, and dead man doors. A dead man door system is where you have a pair of two doors, These are typically found in the entry to a computer room or a document station. And for the second door to function, the first entry door must close and lock with only one person allowed in that holding area. This reduces the risk of piggybacking, where an unauthorized person can follow an authorized person into a secure entry area. Dead man doors. Pretty cool concept. Well, as I mentioned, the last two nuggets of the CISA series are on business continuity and disaster recovery. What we're going to do here as we kind of finish up this five-part series is take a departure and start to look at things like environmental controls. Now, we've been looking really at protection and security and management and auditing of components and resources that are basically vulnerable to human beings. But environmental exposures are typically due to naturally occurring events like a earthquake or a electrical storm, hurricanes, tornadoes, volcanoes, floods, extreme weather conditions. And these things can lead to many types of problems. The weather is very unpredictable, if you haven't noticed already. And so one area of concern for us as auditors is the effect of power failures on our computer systems and supporting environmental systems. Now, typically, our power failures are grouped into four major categories, and these are based on how long it lasts and the relative severity of the failure. At the top of the list here, we have what's called a total failure or a blackout, complete loss of electrical power. This could span a single building, or it could be an entire campus or an entire geographical area based on a storm or an earthquake. Or it could be the inability of your electric company to meet the user demands, let's say during the summer. Now, one level below that is severely reduced voltage, and this is referred to as a brownout. This is when your electrical company can't supply power within the acceptable limits, acceptable ranges. This is basically geographical areas where you've got a strain on electrical equipment due to brownouts, and this could limit the operational life or even cause permanent damage to electronic equipment. Then you have below that, a level below that, what we call sags, spikes, and surges. These are temporary or rapid increases, spikes or surges, or decreases, sags, in voltage levels. And these anomalies can cause loss of data, they can take out power supplies on workstations and servers, they can cause data corruption, network transmission errors, and again, physical damage to things like hard disks and memory chips as well. Then at the low end of the spectrum, as far as environmental vulnerabilities go, we have EMI, or electromagnetic interference. This is caused by electrical storms or noisy electrical equipment like fluorescent lighting or radio transmissions or motors. This interference can cause your systems to hang or crash or cause damage similar to that with sags, spikes, and surges. So as an auditor, it may be your responsibility to kind of ask the right questions to the organization, to your customer and your client, that gets to the heart of the matter related to environmental issues and environmental exposure. You want to ask questions like, is the power supply to the computer equipment properly controlled? Is it within manufacturer specs? Is the air conditioning, the humidity, and the ventilation systems for the computer systems adequate to maintain the proper temperature and humidity? Is your equipment protected from the effects of static electricity by using anti-static rugs or anti-static mats or spray? Is the equipment dust-free, smoke-free, and basically free from other particulate matter like food, for example? Are your admins eating Twinkies around the equipment? Okay? Do you have physical policies in place that prohibit eating and drinking and using tobacco around your equipment? Is your backup media protected from environmental factors? Now, that being said, let's look at some very practical controls and some diagrams and pictures of controls for environmental exposure. As an auditor, you want to check for alarm control panels. Here's a couple of high-end control panels, one from Bosch, for example. So your alarm control panel should be separate from, let's say, the burglar or security system alarms. These are alarms that are accessible to the fire department. They should be weatherproof. They should be in a controlled room with access prevented by unauthorized personnel. They may be on dedicated or separate circuits. They have to control or disable certain zones within your facilities, your organization. They also have to be in adherence to local and national regulations. These are environmental controls. Now, some of these controls will detect fire, some can detect water levels, smoke, other environmental factors. For example, here's some water detectors or water alarms. These should be placed under raised floors and near drainage holes, maybe even in the computer room if it's on a high floor. You're looking for water leaks and water levels. You also want to make sure that handheld fire extinguishers are placed in strategic locations throughout the building, throughout the facility. They should be tagged for inspection and inspected at least once a year. Don't forget smoke detectors and fire alarms. These are a couple of high-end fire alarms and smoke detectors also placed strategically throughout their organization. They should have an audible alarm linked to a monitored guard station. You should have smoke detectors and fire detectors above and below the seating tiles and below the raised computer room floor. Some organizations that are dealing with chemicals or manufacturing, possibly a plant, for example, that manufactures baked goods or something like that, will have a fire suppression system. And this is an advanced system that automatically activates when it detects high heat, typically generated by fire. This system should also produce an audible alarm like a smoke detector and be linked to a central guard station that's monitored on a regular basis. A water-based fire suppression system may have a sprinkler system built in. You've got halon systems. You've got FM 200 fire suppression by discharging gas. You've also got CO2 systems. You'll see these also like water systems, sprinkler systems in a kitchen, for example. For example, like this one. Other things to keep in mind are making sure that you've strategically located your computer room to mitigate against the risk of flooding, for example. Maybe not put it in a basement where flooding is a possibility. If it's a multi-story building, probably the best location is somewhere where it's reducing the risk of fire, smoke, and water damage, like the third, fourth, fifth, or sixth floor. You want to do regular fire inspections. You want to fireproof the walls, the floors, and ceilings. And of course, as you can see in the diagram here, you want to use electrical surge protectors. These can be the smaller units like these, or they can be this APC 500, which is what I'm using here in my small office home office, which does battery backup and or surge protection. So a lot of UPS systems, uninterruptible power supplies, also provide surge protection. And this is going to reduce the risk of damage to equipment due to a power spike. I mentioned a UPS, an uninterruptible power supply. These can be battery or gasoline powered that interface with the electrical power entering the facility and the electrical power entering the computer. You can go for about the $35,000 version here from APC, or if you have $8,000, you can try this option, and they go down from there. Like this practical version for about $800. If a power failure does occur, the UPS is going to continue providing electrical power from its generator to the computer for a certain length of time, from a few minutes to a few days. The purpose here is to get an orderly computer shutdown. You can also have a UPS system built into a computer if you want to. In addition, you may want to go ahead and have a full-blown generator at your site, which can be diesel powered or gasoline powered or battery powered, and to be able to provide more electricity for a longer period of time. And this really goes into disaster recovery or business continuity that we're going to talk about in the final two movies. So as an auditor, here's a nice little list of things to keep in mind that you're looking for when you audit the organization for environmental controls. Make sure that the computer room is located strategically away from fire and water threat damage. Do regular inspections. Make sure these are scheduled. Fireproofing of walls and ceilings and floors. Make sure that generators are available, or UPC. Locate the emergency power cutoff switch. Look into having redundant power lines to multiple sources of power. Make sure everything's fully documented, and then have emergency evacuation drills on a regular basis. In Protection of Information Assets Part 5, we covered 4 key topics. We looked at auditing the IS management framework, auditing network infrastructure security, physical access controls, and then finally, environmental access controls. I hope this CBT has been informative for you. I want to thank you for viewing. We'll see you in the next movie.